Chapter 3.6, we get into proving theorems about perpendicular lines. So the question we're going to ask is, what can we prove using perpendicular lines? And I just want to point out that this symbol right here means perpendicular. It's a shorter way than having to write the word all the time. So the distance from a point to a line is the length of the perpendicular segment from the point to the line. So the shortest distance between two things is a straight line. Theorem 3.8 says, if two lines intersect to form a linear pair and the angles are congruent, then the lines are perpendicular. So for example, if angle 1 and angle 2 are congruent, then G is perpendicular to H. So we're going to draw a picture on the side. So in this picture, if the picture looks like this, so if angle 1 is congruent to angle 2, then we would say that the lines must be perpendicular. And let's call this line G and line H. So line G and line H must be perpendicular to each other if those two angles are congruent. Because if you look at it, if those angles are congruent, they form a line, right? You see how they form this line? Lines add up to 180, so that means each angle would have to be 90 degrees, which would make it perpendicular. Theorem 3.9 says, if two lines are perpendicular, then they form four congruent angles where they intersect. So for example, if A is perpendicular to B, so we're going to draw this picture down here. Let's draw line A, and line B. So if A is perpendicular, meaning it forms a right angle, A is perpendicular to B, then angle 1, we'll call these angle 1, angle 2, angle 3, and angle 4. Angle 1, 2, 3, and 4 are all congruent. Because the measure of angle 1 would equal 90 degrees, the measure of angle 2 would equal 90 degrees, the measure of angle 3 is 90 degrees, and the measure of angle 4 is 90 degrees. All those angles would be 90 degrees because if one angle is 90, right, because they're perpendicular, so one angle must be 90, the vertical angles must be congruent. So if angle 2 is 90, that means angle 3 is 90. And also, this linear pair, like angle 1 and 2 form a line, they must add up to 180. So if this is 90, then this must be 90, this must be 90. So in the end, they all are 90 degrees. Example 1. Draw conclusions. In the diagram at the right, angle 1 is congruent to angle 2. What can you conclude about line A and line B? Well, if we look, if these angles are congruent, how big must each angle be because they form a line? Each angle would have to be 90 degrees because they have to add up to 180 and they have to be equal. So 90 plus 90 adds up to 180, and they're both 90 because they're both equal. So we can conclude that A is perpendicular to B. We can also conclude that two congruent angles form a linear pair so both angles are 90 degrees. That's what we talked about. Two congruent angles that form a linear pair. Both angles must be 90 degrees. Theorem 310. If two sides of two adjacent angles are perpendicular, then the two angles are complementary. Remember, complementary means adds up to 90. So we're going to draw a picture. If we have ray BA and ray BC, and we have a third ray that kind of goes out here, right? And they're saying that we know that BA is perpendicular to ray BC. So what can we conclude? We can conclude that angle 1 and angle 2 are complementary. This means add up to 90 degrees. Which makes sense because that right angle box means 90 degrees. So that means angle 1 and angle 2 combined are 90 degrees. So we have a checkpoint. If C is perpendicular to D, what do you know about the sum of the measures of angle 3 and angle 4? So if they are perpendicular, you know they form a right angle. And remember earlier we talked about, well, if one angle's 90, then they both have to be 90. So we can say that, what do you know about the sum of angle 3 and angle 4? We know that measure of angle 3 plus measure of angle 4 equals 180. Because angle 3 and angle 4 form a linear pair. They form a linear pair. We know they add up to 180, and actually they're both 90, so 90 plus 90 is 180. Couple theorems. 311 says, given that A is parallel to B, and AC, or A is perpendicular to C. So what we're going to draw is a third line. You're going to draw a third line going through here that's perpendicular. This is line C, and it's perpendicular to A. And we also got to show that A is parallel to B. So if we're given that two lines are parallel, and there's a third line that cuts through them, that's perpendicular to one of the lines. What can we conclude? B is perpendicular to C. Because if those lines are parallel, remember this angle and this angle are called corresponding angles. And if the lines are parallel, corresponding angles are congruent. So therefore, this angle would also be 90. So therefore, C would have to be perpendicular to B as well. Right. And then theorem 312 says, in a plane, two lines perpendicular to the same line are parallel to each other. So for example, we're going to draw another line, a third line again. They're saying we're given that A is perpendicular to C and B is perpendicular to C. So your picture looks like this. There's two right angle boxes. What can we conclude? Well, notice where I put those boxes. Those angles, these angles are called corresponding angles, again. And if the corresponding angles are congruent, what do you know about the lines? Corresponding angles congruent would mean the lines are parallel. So we can conclude that A is parallel to B. And just a reminder, this symbol means parallel to. So A would be parallel to B if they're both perpendicular to C. Okay, then we have a couple examples. Determine which lines, if any, must be parallel in the diagram. Explain your reasoning. So let's just do a couple of these. So notice that these two angles are both right angles. Those angles are corresponding because they both are below and they both are to the right. So we would say that R is parallel to S. And the reason is both are perpendicular to line X. We could also say because the corresponding angles are congruent. Notice line Y and line R are both perpendicular. Line X and Y are both perpendicular to R. So we would say X is parallel to Y because both perpendicular to R. Oops, I kind of zoomed away there. And lastly, notice that X and Z are both perpendicular to S. So we'd say X is parallel to Z because both perpendicular to S. So there's a few different pairs of parallel lines, and they're parallel because they're both perpendicular to another line. Okay, checkpoint. For each checkpoint, use the diagram at the right. Is C parallel to D? So C and D, are they parallel to each other? Notice C and D are both perpendicular to A, so the answer would be yes. Both perpendicular to line A. And number 4, let me see if I can erase this. In number 4, it says, is B perpendicular to D? So is B perpendicular to D? So if you look at this, can we conclude that B is perpendicular to D? This one's kind of tricky, but it's yes. And the reason is C is parallel to D. We just said that above. And we know that B is perpendicular to C. So therefore, B is also perpendicular to D. Okay. Okay, and we'll do the last example here now. Find the distance between two parallel lines. The section of broad gauge railroad track at the right are drawn on a graph where units are measured in inches. What is the width of the track? And a hint here is, in order to find the distance between two parallel lines, you must find the length of a line that is perpendicular to both. So if we zoom in, we want to find a line that's perpendicular to both. So if we look right here, this line given to us, if you look, it is going to be perpendicular because the slope from here to here, if you look, the slope of the red line, so M, let's do QR. Slope of QR is Y2 minus Y1, so 55 minus 34, divided by X2 minus X1, 91 minus 71. So the slope of this one would be 21 over 20. Okay. Now let's find the slope of this blue line, just to make sure they're perpendicular. So we'll do PQ, and we'll find the slope. Y2 minus Y1 is 74 minus 34, divided by X2 minus X1, so 29 minus 71. Oops, that looks like a terrible number there. This is 71. So 74 minus 34 is 40. 29 minus 71 is 42, negative 42. And if you reduce this, divide them both by 2, you would get 20 over negative 21. These are opposite reciprocals. So opposite reciprocals mean that these two lines are perpendicular. So once you verify they're perpendicular, now we got to do distance formula. So we're going to do the distance formula for this line right here to see how far apart are the tracks. So the distance from P to Q is the square root of the x's when you subtract them. So take the x's, which are 71 and 29. So 71 minus 29 squared plus the y's when you subtract them. 34 minus 74 squared. This is the distance formula. And just so you know, it comes from this. This was from earlier this year, quite a while ago. So the distance from P to Q is 71 minus 29 is 42. So 42 squared plus negative 40 squared. 42 squared, by the way, make that look more like a 42. 42 squared is 1764. 40 squared is 1600. So the distance from P to Q is the square root of 3,364, which is 58. Okay, so the distance formula was from a while ago. That's this formula up top. We plug in our numbers for the blue highlighted line, and we end up with getting the distance from the distance the tracks are apart is 58. Okay, and that's again showing that the distance between two parallel lines is the perpendicular line between them.